Here we are at example 4 from our 0.4 set of notes. We're asked to solve, in this case, for x. So we're trying to get x all by himself. And we notice that x is down here, unfortunately, on the bottom. And because we don't like fractions, what we're going to go ahead and do is multiply both sides by our LCM. Now in this case, we're looking at the denominators, and we're trying to figure out what is the smallest thing that x and v go into. Well, our LCM in this case would be x times v. Because remember from that rule with LCM, we could just multiply all the bottoms together, and then that's a common multiple. In this case, it actually also comes out to be the least common multiple. So what does this look like? If we multiply both sides by xv, well, we're going to multiply the whole left side by xv, as well as our whole right side by xv. And just to kind of show it the longer way, because we do have a lot of variables, we're going to go ahead and multiply the tops together. So in this case, we would end up with x times v times k, all over, keeping the bottom, x, equals, on the right side, we're going to go ahead and multiply again the tops. So we have w times x times v, all over v. So again, we haven't touched the bottoms at all, we just multiplied our tops together. Now we can go ahead and simplify. Well, we notice that on the left side of the equation, our x's end up canceling out with one another. That's a good thing. Something should cancel like that. That's the point of the whole LCM and clearing fractions. Leaving us just with our vk. On the right side, we notice our v's end up canceling. One's on top and one's on bottom, leaving us just our w and x. Now, if our end game is to try and get x all by himself, well, this wx is kind of like a coefficient, some number in front of x. So because it's stuck and glued to x, what we're going to do is divide both sides by w. On the right side, they end up canceling, leaving us with just our x that we want, equals v times k all over w. And there it is. We again have solved for x, and that is example 4 from our 0.4 set of notes.